Parallel, intersecting, perpendicular, irregular.
When two lines will never touch, then you can tell that those two lines are parallel. Like these telephone wires up above the street. Parallel lines will never meet.
Parallel lines never meet. Intersecting lines make these. Perpendicular lines meet at 90 degrees. Put your hands in the air with me. Parallel, intersecting, perpendicular, irregular.
Hello again, Algebra 1 students, and welcome again to another exciting edition of Algebra 1. We're looking at solving special systems of linear equations in this section, 5.4. So we've been solving system of equations using graphing, the substitution method, and the elimination method. And we always noticed that we got one solution. That was what we were looking for, is where those two lines intersected. So we're looking for intersecting lines, and in this one we're going to have some special systems. There's going to be two of them, and you can see on the essential question here it says, can a system of equations have no solution or infinitely many solutions? Those are the two special types of solutions we're going to see. Yes, they can. A system can have no solution, and a system of equations can also have infinitely many solutions. So that's what we're going to see, and that video about parallel lines kind of gives you a clue that what we're going to be talking about is some parallel lines in this one. So that's what we're doing today. Let's go ahead and look at our cartoon here. We got a Garfield cartoon. It says, "I hate Mondays." And just why do I hate Mondays? And then everything crashes on top of them. I guess that's the table, because Mondays hate me. Garfield. Loved Garfield for such a long time. All right, let's move on to our lesson now. Alright, so on page 149 you'll see the core concept that says solutions of systems of linear equations, and we do have three different types of solutions. We already know about the one solution where we get one intersecting point. Okay, we've done those now for three sections really, so we've known about these ones. One solution, those are still in effect here, but we're going to now learn about these other two. A no solution one is where the two lines are going to be parallel, so there's where the parallel lines come in. If your two lines are parallel, they will never touch, they'll never meet, and so that means there's no intersecting point, there is no solution then. Now if the two lines were the exact same line, the lines are the same, one is going to be right on top of the other, that means they're going to be touching and intersecting at every single point. So that's why there's infinitely many solutions if they're just always going to touch. So that's why we have three types of solutions. We have a one solution, which is going to be still at intersecting point, and if we had a system of equations, so we got to look out for those, and that's going to be the most often time you're going to see a system, is you're going to get a one solution. But there are going to be an occasion where you got to know that you're going to get a no solution on this one, or there might be an occasion where it's infinitely many. Now we've been talking about these even when we did just regular solving equations. So as you can see on this screen right here that I have before you, these are just regular equations, just solving these equations for D or for N, and down here A, B, or C, you're going to have one solution, no solution, or infinitely many. So we've still been talking about these even in the past. Sometimes we're going to get one solution, N will equal just a one number, or sometimes it's no solution, and remember when that was true is that the N's were going to cross out, or something's going to cross out. That's kind of like on 36 right here. You see 5D on both sides. They would cross out. If I subtracted 5D from both sides, they're going to cross out. And so now I no longer have my variables, so I know I don't have one solution there. Instead, it's going to be one of these two. And since -8 does not equal 1, it's a no solution. If it was true, then it would be infinitely many. So if you have the same thing on both sides, then it's going to be infinitely many solutions. So now that we come into systems of equations, we have the same thing going on here. This is the graph form of that, but obviously we're going to see them in equation form. So we have to realize that, again, one solution, we would try starting to solve the equation. system of equations, if we can continue solving for a variable, then we want to keep going and get the two x and y variables for that intersecting point there. But if we somehow cancel out our variables, if both variables are going to cancel out, then it's going to be one of these special ones here. And we need to realize also another thing is if we can see the equations in like slope-intercept form, if they have the same exact slope, then they're parallel lines. And we know if they're parallel lines, then it's no solution. So if we can identify them in slope-intercept form and see that they have the same exact slope, then we can quickly just say there's a no solution answer. Or if we could see that they're exactly the same equation, if somehow we can maybe adjust the equations so they're exactly the same equation in both of the equations, they're identical, then we can say infinitely many. Okay, so on page 150 we have our extra practice, and throw 1 through 6. I'm going to do the even ones out of here, and I'm going to have you do these odd ones. So you'll do 1 through 3. Well, let's take a look at 4, 5, and 6 first. And so we're going to start with looking at, we have the two system. Here's the system. We have two equations in two variables. So we call this kind of a 2 by 2 system. And we can see, first of all, if I was going to go ahead and do the elimination method, which this is set up for the elimination method, we just saw that in 5.3. What we could do here is we could say, well, the x's are going to cancel out right away, so I have no x's, but the y's are going to cancel out also, and so they're canceling out, so now I have nothing on this side except just 0. And then on the other side, I have 6 plus 3, combine those, and that gives me 9. So is this a true statement? So we know if we cancel both of them out, we're not getting one solution. This is a special one. It's either going to be no solution or it's going to be infinitely many. Now, same idea applied when we were doing those equations. We're looking at those. If you get a true statement here, it's infinitely many, but if 0 does not equal 9, which is in this case true, or 0 doesn't equal 9, obviously, then it's no solution. So this is going to be a no solution answer because this is not correct. 0 does not equal 9. So no solution on this one. So we can put a little slash through the equal sign. On number 5, let's go look at 5 here so we can see on this one, if I'm going to do the same thing with elimination, because it's all set up for elimination, and I'm going to say, okay, I'm going to cancel out my x's, the 6 and negative 6. I can cancel out the y's also, 6y and negative 6y. So again, 0 on this side, and over here, negative 3 and 3 is also going to make 0. Well, this is true. This does equal, and so this one would have infinitely many solutions. So we say infinitely many solutions. Oops. So, all right, number 6. For this one, set up for elimination again. It's all lined up. But this time, 2x and 3x would combine and give me a 5x. And I'm going to cancel out my y's. Those do cancel out. So I didn't get to cancel out both variables. So this one is going to have one solution. So here was a no solution one when we canceled out these both areas and got a nothing that didn't equal 0, did not equal 9, so it's no solution. This one we canceled out the variables, but 0 did equal 0. This was true, so it's infinitely many. Now we're going to get one solution out of this one, and we want to find out what that solution is. So it doesn't just say determine, it does say solve the system. So we do want to figure out if it's going to be a solution. Take 3 away from 8, that's a 5, and then just divide by 5 on both sides. So that's going to be 5 divided by 5 is 1. X is equal to 1. And then we want to pick one of these equations here. I'll just pick I'm going to pick the bottom one where y is positive. And so I'm going to go and use a different color. I'm going to do that. So using the bottom, 3 times x. So that's going to be 3 times 1 is just 3. So we can put times 1 if we want to. That's just a 3 there. Plus 5y equals 8. And so this is just a 3 here. I'm going to subtract 3 from both sides now. And then 5y, this cancels here, is equal to 8 minus 3, which is 5. So in this one, y is also equal to 1, as you can see. When I divide by 5, y will equal to 1 as well. So our solution for this guy right here, for number 6, is 1, 1. So that is the one solution there. Alright, so go ahead and pause the video at this point and try 1, 2, and 3 and see if you can figure out what the solution is. If it has no solution, you'll write that down. If it's infinitely many, write that down. But if it does have one solution, find that solution as an ordered pair. Alright, so hopefully you had enough time to do 1 to 3. So number 1, you should be able to look at that one. It's in slope-intercept form on both of those equations, and they have the same exact slope. So the slope right there is 3x and 3x. So if they're the same slope, we don't have to do any more than just know these are parallel lines because they're different y-intercepts. If they have the same y-intercept, then they're exactly the same line, and then that'd be infinitely many. But since they have different y-intercepts, they are going to be separate lines, but they will have the same slope, so they're going to be parallel lines. And so since those are parallel lines, then we can definitely say that those are going to have no solution on them. So they are parallel lines, so that means the answer is no solution. And then for 2, you can see these ones also they're both in slope-intercept form, y equals mx plus b, but they have different m's here, 5x and negative 5x. So those are not parallel. They don't have the same slope. So these ones are going to be more intersecting lines. What we actually could do is, since they are both lined up, the y's are lined up, x's and the numbers here, I could do elimination on this, just the way it's lined up here. And I could say y and y make 2y equals, cancel the x's out, and then take 1 away from 5, and I should actually gotten 4 here. That's right, let me fix that. Okay, so that's better now. I fixed that. So it should be 2y equals 4, and then that means y equals 2. And I just pick the top equation then to plug the y back in. And so doing that, I'm going to get 2 equals 5x minus 1, and then add 1 to both sides. So 3x equals 5x, or 3 equals 5x. Divide by 5, and we end up with a fraction for x, 3/5. 3 divided by 5 is a 3/5. And so our answer there is just an ordered pair of 3/5 for x, comma 2 for y. And then for number 3, it's all lined up, so we're going to be canceling out the x's, we cancel out the y's as well, we cancel out the 10's, and we get 0 equals 0, so that's an infinitely many solution situation. When you cancel everything out, then that's infinitely many solutions. You could also multiply, like let's say this bottom equation all by a negative, and it will become exactly the same. It will become 2x minus 3y equals 10, and that's exactly what we have on the top. So those are the same. They really are the same equation, because we could just multiply the bottom all by a negative and make it the same equation. Alright, so on 7 to 12, so 7, 8, and 9 is the bottom of 150, and then 10, 11, 12 is at the top of 151. So I'm going to go ahead and do these ones here, 10 to 12, and then I'll have you go ahead and do 7 to 9. So with 10 to 12, the same idea. These are lined up, x's, y's, and the numbers over here. So as I cancel out my x's here, they'll cancel out. The y's are going to cancel also, so we can make it 0, so this is a special one. And the 21's cancel. So there's an infinitely many solutions answer. Infinitely many solutions, infinity. So basically infinity, yeah. Infinity. Get an E in there. Infinitely many solutions. Going on to 11. Same thing as far as elimination method. They are all lined up. But as I look at trying to cancel something out, there is nothing to cancel out, in fact. So for this one, I'm going to have to solve it. So if there's nothing I can cancel out, is there any way, could I make these the same equation? No, I can't do that either. So we're going to end up getting one solution for this one. So we need to figure out, well, what do I need to multiply, 3 and 8 by to get to the same number? So if I just start by counting by 8, obviously 3 can't go into 8. So starting with 8, that doesn't work. Going to 16, 3 does not go into 16, go to 24, and 3 does go into 24. So this one we would multiply by 8 to make this 24, this one times 3. So just by the same numbers we have here. And so I'm going to go ahead and just put those down below here. So we're going to see it's going to be 24x. Now I'm going to need these to be opposite signs. Let's go ahead and make one of these a negative. I'll make that a negative 3. So again, this is an 8 right there. 8 times 3x, 24x. 8 times 8, negative 64y is equal to 8 times 3 is 24 there. And then again, negative 24x, negative 3 times negative 3 is giving me positive 9y. And then negative 3 times 8 is negative 24. was negative 24. So now, when I combine these together, we'll cancel out these x's. So x is 24 minus 24, those are going to cancel out. But then I take 9 away from 64, that does make a negative 55. 55y is equal to, and 24 and 24 here cancel out, so that's 0. So really y is going to equal 0. So if y equals 0, we pick one of these equations. Let's just go to, I don't know, let's say the top one here. That'll be fine. Number's a little smaller, maybe two, got a couple 3's in there. So 3x minus 8 times 0, so that's going to be going away. So 8 times 0, so minus 8, plug in 0, equals 3. So that does go away. Negative 8 times 0 is 0, and now we just see 3x is equal to 3, so x is equal to 1. So our ordered pair for this one, I'm going to put it down at the bottom here, is 1 for x and 0 for y. That's our answer. Our 1, our single answer, that's the point of intersection. And then for 12, looking at this one, okay, so far it is lined up, but again, it's not, and nothing can cancel out. So what I could do here is figure out what should I multiply 3 by to get an 18. That's going to be 6, and I would need to make it a negative 6. So we're going to multiply by negative 6 here. I'm going to try green on this one. So negative 6. And so that's going to just multiply the bottom here, and I'm just going to kind of put it right on top of this. Or maybe I'll put it on the side. Let's go ahead and rewrite this one. Oh, no, I'm going to put them both underneath. So here's my 18x plus 12y. I'm just going to copy the top one. So this is me copying the top equation. And now negative 6 times 3x is negative 18x. Negative 6 times 2 is negative 12, so negative 12y. And negative 6 times 6 is negative 36. And so now we're canceling out our 18's here. Those cancel. 12 and negative 12 also cancel, so we end up with 0. We're getting a special one. So now we see, okay, what's on this side? 24 minus 36. Well, that would be just subtracting. That's a negative 12. And obviously that's not equal. 0 is not equal to negative 12, so this is a no solution answer. So we get no solution on that one. Alright, so again, pause the video and then try 7 to 9 on your own, and then go ahead and play it to check your answers. Alright, so hopefully you should have answers for 7, 8, and 9. So number 7, you can see we're going to cancel the x's out, cancel the y's out. Actually, no, we're not canceling y's out, just x's only. So we are going to get one solution on this one. So this would be an example of a common mistake you could make. You can think, well, I'm going to cancel those out, and 3 and 3 cancel out, but they actually don't because they're not opposites. So by saying no solution, that would be a common mistake. So don't just quickly say no solution. You got to make sure you're going to definitely cancel both of those out, and these 3's are not going to cancel. So let's see what the answer really should be. So here's what the answer really should be. So 3 and 3 make 6y, and then this is the negative 6 here. So when you divide by 6, you're going to get negative 1 for y, and I just chose the top equation to plug in that negative 1 to. So 2x plus 3 times negative 1 equals 1. And then when you solve for x by doing that, 2x minus 3 is equal to 1, adding 3, then eventually you divide by 2, x is equal to 2. 4 divided by 2 is 2. So if x equals 2, it's 2, comma 1 for y. So 2, comma 1 is our ordered pair solution. So that's our one solution. Now when we come to number 8, we notice, okay, I can't cancel anything out yet, but I could see, oh, if I want to try to cancel out x's, I would multiply the top equation by 2. So we want to do that. Multiply your top equation by 2. So we rewrite that below here. Just going to write it right below this bottom one. And that's going to give us a 2 times 4 is 8x, 2 times 3 is 6y, and 2 times 17 is 34. And we'll be able to cancel out x's, cancel out the y's, but the 34's don't cancel. And so we get 0 equal to 68, and obviously that's not equal to, so it's a no solution answer. So we got no solution on 8. Number 9, same thing going on here. We can't cancel them yet, but we could see what do we need to multiply 3 by to get a negative 9. or to get an opposite of negative 9, I should say, it would just be 9. So 3 times 3, we want to multiply the top equation of this one by 3. So 3 times 3 is 9x. I'll put that right below. 3 times negative 2y is negative 6y. 3 times 6 is 18. So we're going to cancel out the 9x's. We can end up canceling the 6y's as well. They're opposites. And the 18's are also opposites. So they cancel out. 0 equals 0, which is a true statement. So it's infinitely many solutions on number 9. Alright, let's go on to our joke of the day. So a mom texts, "Hi son, what does IDK, LY, and TTYL mean?" And he texts back, "I don't know, love you, and talk to you later." The mom texts him, "It's okay, don't worry about it, I'll ask your sister, love you too." She didn't realize that's what he was telling her, that this is what they meant. Alright, let's move on to our next section. Same page that we were just on 151. And again, I'll do 16 through 18. You guys will do 13 to 15. So number 16. So when we look at this one on 16, again, things are all lined up for elimination, but I can't eliminate anything yet. You need to figure out, okay, what could, these both become? They could be just both become 35. It's the closest thing. So you're going to just have to multiply them by their numbers. So this one times a 7 will give us 35x. This one times a 5 will give us 35y. And it has to be negative here, so that way it will cancel each other out. So I'm going to go and just put them down below here. So we're going to see 35x, 49y, and 49. And from our second equation, we get negative 35x, and we get negative 25y, and we get negative 25. So when I cancel things out here, I'm only going to be canceling just the x's. So we are going to get one solution on this one. So 49 minus 25, that's going to be 24. 24y is equal to, and we get the same thing over here, 49 minus 25 is also 24, so y is equal to 1. And so I just choose one of these equations. I'll go ahead and choose the top equation. So I just choose this top equation here, use this one, 5x. So 5x plus 7y, so 7 times 1 is 7, equals 7. So I just subtract 7 now from both sides. That's going to give us 5x. These 7's cancel, and 7 minus 7 is 0. So if I divide by 5, it's just giving x is equal to 0. So our answer on this one here is an ordered pair. X is 0, but y is 1. 0, 1 is the one solution. That's where these two lines will intersect. So if I graph them, again, it has an intersect. They are intersecting lines, and they intersect at this ordered pair 0, 1. Okay, number 17. So this one, they're both in slope-intercept form. Again, let's take a look at their slopes. 2/3, 2/3. Those are the same slopes, and they have different y-intercepts, so that means that these are parallel lines. So if they're parallel lines, right away, I know that the answer is no solution. So very quickly, just by looking at those slope-intercept forms, I can see they're parallel lines. So you want to be able to identify parallel lines when you see them, when they're both in the slope-intercept form of y equals mx plus b. Now number 18, there's another one where they're set up for elimination, but I can't eliminate anything yet, but I can multiply this by 3 and again opposite of 9. So I'm going to multiply my top here by a 3. So 3 times negative 3 is negative 9x. 3 times 5 is 15, so plus 15y. 3 times 15 here is 45. And so as we now look at these two equations, we're canceling out our x's, the 9x's. 15 and negative 15 cancel out, so I make 0 on this side, and equals on this side. 45's also cancel each other out, they're opposites. So here's another infinitely many solutions. That's true. 0 does equal 0. Infinitely many solutions. Alright, so go ahead and pause the video and do 13 to 15, and then play it to check your answers. Alright, right, so take a look at our answers now from 13 to 15. So the first thing you'd want to do on this one is, you can see, you're going to multiply the bottom here by -3. So if I try to cancel x's out, that will work with -15x. So I'd rewrite this one, maybe right down below, and then multiply in by -3 on all of these. And so it gives us -15x, +6y, -3 times 27 is -81. And so we're canceling out 15x's, canceling out the 6y's, but then 9 and -81 make it -72. So that does not equal. 0 equals -72, no solution. That does not equal that. I forgot to put the little slash there, but yeah, you could do that. On 14, we would want to notice that we need to multiply the top equation here. If I want to cancel out the x's, just multiply by 2. That makes a -6x on the top one. So multiply the top equation by 2. That would give us a -6x here, -10y, and then 16. And so that's going to cancel out our 6x's, cancel out 10y's, cancel out the 16's. 0 does equal 0. Infinitely many solution answer for 14. So we got a couple special ones there where we crossed out both variables, but again, this one, we didn't cross out the numbers on this side, so that's no solution, because that's not correct. 0 does not equal -72. But when we cancel everything out, including the numbers on the other side, 0 equals 0 is an infinitely many solutions problem. If instead, if I multiplied this by -2, it would have been exactly the same equation I would have got here. So they would have been identical. You could see it's the same line. Remember, if it's the same line, one right on top of each other, that's why they're always going to be intersecting and touching. And then for 15, we want to cancel out the x's already, but we can't cancel out the y's. We end up getting -8y there, and then +8 on the other side. So when I divide by -8, I get y equals -1. So we are going to get one solution for this one. So I'm going to go ahead and use the top equation and plug the -1 in for y here. So 2x minus 4 times -1. That's going to make +4 there. Subtract 4 from both sides, giving us -2. So now 2x is equal to -2. Divide by 2, and x is equal now to -1. So there's our answer then, -1 and -1. Both x and y are -1. So there's the one solution. So these are intersecting lines, and they will intersect at the ordered pair of -1, -1. Okay, so right there at the bottom of 151, our last problem, number 19. It's always a situation problem, and we have to write out the system of equations on this one. It says you have $15 in savings. Your friend has $25 in savings. You both start saving $5 per week. So write a system of linear equations that represents this situation. So we would say that it's going to be like a y equals mx plus b situation. So if we say y is equal to, y would be the amount of money you would have in your savings account when you calculated it. 5x is going to be the savings. You're going to do 5 per week. So first week is 5. If you put 2 weeks, 2 times 5 is 10 now you have in your savings, added to your savings. 3, if 3 is x for 3 weeks, it's 15. So that's what we get to say for both of you, really, for you and your friend. So you have 15 in savings already, so that 15 is going to go back here. So you already have an initial amount of 15, and now you're just going to keep adding $5 per week, and that will give you your total amount. So y is like the total amount. Your friend, also, y is going to be the total amount. He's going to also save, or she's going to save $5 a week, and $25 in your friend's savings. So as you can see, we have two slope-intercept equations. So your friend has $25 initially in their account, starting in the account, and they're going to be adding $5 a week to it, just like you are. So the question is, so there's our system. It says write a system of linear equations that represents a situation. There's the system. Will you ever have the same amount of savings as your friend? So the answer to this would be, is there a point of intersection? Is this system ever going to intersect? And you can see no, because it's the same slope. These are parallel lines. And parallel lines never intersect, so the answer to this one is no. No, you will not have, you wouldn't necessarily say no solution on this question, But you would say no. The answer is no, and the reason is parallel lines. These two are parallel lines. They never intersect. Never intersect. So that means they're never going to have the same amount. These are never going to be the same amount. X and Y are never going to be able to be the same thing. All right, so with that, I'll say adios and arrivederci. Have a great rest of your day, and I'll see you on the next lesson.